So now we're going to solve some quadratic inequalities. This comes into play in some higher mathematics. Now, we've solved some quadratic equations using the quadratic formula or factoring, but these are going to be inequalities, meaning I'm going to have a bigger than or equal to, or less than or equal to. So here's the standard form. And for this example, we'll say it's bigger than 0. We could say bigger than or equal to 0. Or less than 0 or less than or equal to 0, whatever the case is. In this case, it would be as though we were looking for positive values. This is called standard form. So for this first example, we're going to start out, we're going to keep it relatively simple. We're already going to be factored. We'll get to one where we have to factor. And the first thing that we're going to need to do, well, let me start here. I have the x minus 4, x plus 3 multiplied together, and when I multiply those together, I need to have a value that is bigger than 0. That's what I'm interested in. So I need to find which values are going to give me a product or multiplication of positive numbers. First off, I need to find what are called critical values, and that means I'm going to set each piece equal to 0 because I want to know where the breaking point is. So I'm going to have the x minus 4 is equal to 0, which means x equals 4. And the x plus 3 equals 0, which means x equals negative 3. And these are called critical values. Meaning this is a breaking point. And what I'm going to do is I'm going to draw a line. This is just a guide to help me out. And I'm going to write down my breaking point. So I got my negative 3 here. I got my 4. And what I'm going to do is I'm going to section this off and I'm going to break it down into 3 separate areas. And I want to know which values of x are going to give me, in this case, positive values. So I'm going to choose a number that is on the left-hand side of negative 3, meaning something really negative. Let's pick x equals negative 100. Doesn't matter. Somewhere over there. Well, I'm going to go ahead and plug that into the left-hand side, and that's going to give me negative 100 minus 4 times negative 100 plus 3. Now, that obviously, negative 100 minus 4, I don't care what the value is, it's negative 104, but I'm interested that it's going to give me a negative value. Times negative 100 plus 3, again, is going to give me a negative value. And I know that when I multiply a negative times a negative, that gives me a positive. And that really is all that I'm interested in this case. So I'm going to go ahead and write a positive on my graph up here. So anything less than 3 is giving me positives. Let's check in between. Let's now test if x equals, we'll say 0. 0 is between negative 3 and 4. Nice, easy number to use. And I'm going to go ahead and plug those in again. 0 minus 4 times 0 plus 3. Now, 0 minus 4 is going to give me a negative value. I know it's negative 4, but I don't care. It's negative. That's all I care about it. 0 plus 3 is going to give me a positive value. Again, I'm interested only in the signs. And I now know that negative times a positive is going to give me a negative value. So on my graph up here, everything between negative 3 and 4 is going to give me a negative value. Lastly, I'm going to check my last section. And we'll pick a big number again. Let's say x is equal to 100. That's something definitely bigger than 4. And I'm going to test it. So I have 100 minus 4 and 100 plus 3. And 100 minus 4 for sure is a positive value. Don't care what the number is. 100 plus 3 is also a positive value. And I know that a positive times a positive is going to equal a positive. Now I'm going to go back up here, put down my positive, and I'm going to look at the original inequality, and it says all the values that are bigger than 0. And looking down on my graph, I have that everything that is less than negative 3, so negative infinity to negative 3, gives me positive values. And skipping over a region, everything from 4 up to positive infinity also gives me positive values. So my answer is going to look like this. I'm going to have that the values are negative infinity to negative 3 in parentheses because we don't have it equal to 0. If it was equal to 0, then we would have it. Put my open circles here. Union with positive 4 off to infinity. Notice we're skipping everything between negative 3 and 4 because those values are negative. And there's my answer for that one. For my next example, I'm going to have x squared minus 6x is less than or equal to 0. Notice I have equal to in this case. First thing I'm going to do, I'm going to notice it's not factored like the previous example, so I'm going to need to factor it, and the greatest common factor on the left-hand side is x. So now I need to find my critical values. So I'm going to set each piece equal to 0. Which means x is going to equal 0, or x minus 6 equals 0, which means that x equals 0 is one critical value, and x equals positive 6 is my other one. So those are my boundaries. I'm going to go ahead and draw my graph. Putting down my critical values, 0 and 6. And I'm going to put a solid dot here because they're equal, just to remind me that I'm going to include the endpoints in this case. And now I'm going to test values on all three sides. So numbers less than 0, numbers between 0 and 6, and numbers bigger than 6. So let's start out and test again if x equals negative 100. Well, that's going to give me negative 100 times negative 100 minus 6. That's going to give me a negative times another negative. Again, I don't care what the values are, I'm just looking for the signs. And I know a negative times a negative is a positive. So all the numbers less than 0 are going to give me positive values. Next up, if x equals, we'll say 1. That's a number that's between 0 and 6. Any number would work. You could use pi if you wanted. So when I plug in 1, I'm going to get 1 times 1 minus 6. That's going to give me a positive value times a negative value. Again, I don't need to know that that's negative 5. I just need to know that it's negative. A positive times a negative gives me a negative. So I know that all of the numbers between 0 and 6 are negative values. Last up, let's try x equals 100 again. If x equals 100, I'm going to get 100 times 100 minus 6. And that's going to yield a positive times 100 minus 6 is definitely positive. And a positive times a positive is a positive. Which means all of the values that are bigger than 6 are going to give me a positive result. Now, when I look back up at my original equation, I want to know where all the values are less than 0. Meaning, which values are negative. In this case, that is only the region between 0 and 6, and because of the equal symbol, I'm going to include the endpoints. So my answer is going to look like this. A bracket, 0, comma, 6, and another bracket. The brackets again imply that I am including those critical values, those endpoints, because those are the values that make it 0. So the answer actually says it's all the numbers between 0 and 6, as well as 0 and 6 themselves, are going to make the top expression less than 0. One more example. I'm going to have x squared plus 2x minus 8 is bigger than 0. So the first thing I need to do is factor this. And you can factor however your teacher taught you how to factor. In this case, we're going to get x minus 2 times x plus 4 is bigger than 0. So now I'm going to look for my critical values again. X minus 2 equals 0, which means x equals 2. Or x plus 4 equals 0, which means x equals negative 4. So here are my two critical values, or my critical points. draw my graph to help me figure this out. Put down my critical values. So I now have, that's right, it's bigger than 0, which means I'm not going to include the endpoint, so I'm on the open circles there. And now I'm going to be looking at the regions between, or less than -4, between -4 and 2, and bigger than +2. So we'll start out with a value that is less than -4. Let's pick -100 again. So I'm going to get -100 minus 2. I'm going to use the factored form, it's a lot easier. -100 plus 4. Now, that first expression is going to give me a negative for sure, and the second expression is also going to give me a negative. And a negative times a negative is a positive. So all the numbers less than -4 is a positive value. Next up, let's say x equals 0. When x equals 0, I'm going to get 0 minus 2 times 0 plus 4. That's going to give me a negative value times a positive value, which gives me a negative overall. So all of the numbers between -4 and 2, when I plug them into the original expression, are going to give me negative values. Last up, if x equals 100, again, you don't have to pick these exact values, you just need something bigger than 2. So I get 100 minus 2, 100 plus 4. 100 minus 2 for sure is going to give me a positive value. 100 plus 4 is going to give me a positive value, which gives me a positive times a positive, which is a positive. Now, you may think that you start to see patterns here. Do not rely on that. Sometimes things go really crazy and the patterns fall apart, so you actually need to test in all 3 regions. Now, going back to the original problem, they want to know when I am bigger than 0, meaning where is that expression going to give me positive values? Which values of x are going to make that expression greater than 0? And in this case, that's going to be everything less than -4, not including -4, and everything bigger than +2, not including +2. And here's how that notation is going to look. I'm going to go -infinity to -4 with a parenthesis, union with 2 up to infinity. And there you have it.